One thing to note about altitude is that it only decreases to a certain part of our atmosphere. So for the part that we can go to, it's going to keep decreasing with altitude. But then, as you can see in the stratosphere, it actually increases in temperature as we go higher into the atmosphere. And then when we hit the mesosphere, it's going to decrease in temperature. And then finally in the thermosphere, it's going to increase in temperature with increased altitude. Cloud coverage and albedo. Albedo is the fraction of total radiation that is reflected by any surface. So many clouds are going to have a high albedo, or it's going to reflect a lot of the solar energy that comes in. Maximum temperatures on a very cloudy day are actually going to be lower than on a clear day. But it has the opposite effect at night. So cloudy nights are going to keep the heat in. So what you're going to find on a cloudy day, if it goes over 24 hours, is that during the day it's going to be cooler, but during the night it's actually going to be warmer. So the temperature difference is going to be less. This is a visual showing you that the radiation comes in, it hits the cloud, and then it goes up. But at night we have thermal energy coming from the earth, and it's going to be kept in by the clouds, much like a blanket. So albedo from highest to lowest. Snow has the highest albedo. It's going to reflect about 95% of the radiation from the sun. Ice is pretty close. It reflects about 60% of the radiation coming in from the sun. Land is not as good. It's going to reflect about 30% and absorbs on average about 70%. Water is not very good at reflecting at all. It actually has the lowest albedo. It reflects about 6% of the radiation, and it holds in about 94% of the radiation. So ocean currents also help keep warm water from the equator to the poles and cold water from the poles to the equator. This offsets the unequal distribution of radiation from the sun and regulates global temperatures so that it's not scorching hot at the equator and not super freezing at each of the poles. This shows the visual, so we can see the blue arrows coming in from the poles to the equator, then the red arrows going from the equator to the poles. That is the circulation of water in the oceans. So climate depends on many of the same factors that heat does. So we already talked about latitude, elevation, water bodies, but I want to talk about atmospheric circulation and vegetation. Atmospheric circulation is much like ocean currents. We have global winds that are going to transfer heat and moisture around the earth. Winds are going to be moving warm air towards the poles, and then cool air from the poles to the equator. And then low pressure zones at the equator are going to experience a lot of clouds and precipitation. So the equator is going to experience more thunderstorms, more rain. Vegetation is also really important because plants not only depend on climate, but the climate depends on plants. Plants are able to absorb a lot of the sun's energy and regulate the temperatures in that area. And they also release water vapor from their leaves into the air. That's called transpiration. So climate changes are going to be short-term or long-term. Some of these are going to be natural processes and others are going to be due to human activity. The natural processes are going to be volcanic eruptions that release a large volume of ash and dust into the atmosphere. Then ocean circulation changes are going to fluctuate and change precipitation patterns. Solar activity like sunspots and increased radiation are going to cause short-term climate changes, and Earth's orbit and tilt of the Earth on the axis is going to lead to changes in climate as well. And the greenhouse effect is, like I said, keeping us alive, really. We are experiencing a time where water vapor and carbon dioxide are the main factors that affect the greenhouse effect. And if we keep putting carbon dioxide into the air, we're going to get an out of control greenhouse effect, meaning that all of the heat is going to be kept in the atmosphere. If there's too much of these major gases, the heat can't escape into space. We want some of it to escape. So it's important that the greenhouse effect exists, because if it didn't, all the heat would transfer into space and Earth would just be a big ball of ice. But with too much greenhouse effect, it's going to keep too much heat inside.